Here's an example of a relative frequency, or sometimes also known as experimental probability exam question. On 3 days, Ali throws darts at a target. Here are his results, and you can see them there. Work out 2 different estimates for the probability of Ali hitting the target. Well, there's actually a possible 4 different answers that I could use. I just have to pick 2 of, because if I wanted, I could use the data from Monday, or the data from Tuesday, or the data from Wednesday, or I could use the total data. I'm just going to do Monday and Tuesday because they're the top 2, but it doesn't really matter. So if I look at Monday's data, the probability of him hitting the target, well, he hits the target 15 times out of 20 throws. So an estimate for him hitting the target using that data, Monday's data, would be 15 twentieths, or 3/4, or 0.75. And then using Tuesday's data, he hits it 22 times out of 30 throws. So the estimate would be 22 out of 30. And these are estimates, and this is always the case with experimental probability or relative frequency, because it's not exact. I can't measure it like when I roll a dice or spin a fair spinner. It's just using the experiment. So it's not exact, it's an estimate. Part B says, which of your 2 answers is a better estimate for the probability of Ali hitting the target? Well, always with a relative frequency or experimental probability, the more you do the experiment, the more you do the trial, the more accurate your data is. So on Monday, he did 20 throws, and on Tuesday, he did 30 throws. Now, if I'd gone on to do Wednesday or total, they would have been the better estimates. Total would ultimately be the best estimate, because that's using all 90 throws all together. But the question actually says which of my 2 answers. So of my 2 answers, well, Monday was 20 and Tuesday was 30. So the Tuesday data is going to be a better estimate. And the reason for that is he did more throws on Tuesday.